Hello, everybody. Welcome to another edition of the MakeCode Arcade Advanced Stream. I am Richard Avatar on the MakeCode Forum.
And I'm Thomas at Sparks on the MakeCode Forum.
And today, well, first, I guess let's talk about what we did on Wednesday of last week. So on Wednesday of last week, we were kind of looking at our game engine. That's just what we ended up doing. It's not what we were planning on doing. To look at performance issues. And we ended up finding a bug also. So we were kind of looking at, like, why do games get slow when you have so many sprites? You know? And what improvements can we make there? And while we were doing that, we were reading through the code and it was like, hey, this shouldn't work. And so we made a little test project and determined that, hey, it doesn't work. Which is specifically, so if we look at this project we have right here, we have a very tall sprite and we have a very long sprite. And you can see that when these overlap, it should set the background color to red. But they're overlapping and that's not happening. And the reason that's not happening is because we determined that the overlaps thing is only checking the corners of the sprites. So this doesn't work. But if I move my sprite down, there we go, we get an overlap, which is right. All right, so originally I was planning on us just going back to making games today, but I thought it would be fun to instead walk through the process of how we fix a bug like this. Today is going to be a little in the weeds, just so you know, but hopefully it'll be fun. I guess to get started, I've already set up my developer environment on this computer a little bit, but let's take a look at that. So I'm going to go ahead and open up a terminal. So if you're curious, I'm running a Windows subsystem for Linux on Windows. So this is Ubuntu running on Windows, which is my preferred way to develop stuff. In college, I learned on Linux, and I used a Mac for development for many years on the MakeCode team. So I'm just used to the Linux style commands and stuff. So that's what I prefer to use. All right. So I've already got my repos checked out. Hit ls. You can see we have PXT Arcade and PXT Common packages. Those are the ones that we're going to be using today. PXT, I also checked that, but we don't actually need that. And so the game engine lives inside of PXT Common packages. Let's go ahead and open that up. But actually, before we do that, we need to make it so that we can actually change things and see the results, right? So the way that we do that is by serving our website locally. So this is going to create a server that will serve the website on my computer. You won't be able to go to it, but I can go to it on my computer so that I can test things. And as we change things, the website will reload. We'll see our changes. That's kind of how the dev loop works. So to do that, I'm going to cd into PXT Arcade and start a server. So let's go ahead and go into PXT Arcade. And in PXT Arcade, I already have my node module set up. But if you look at the PXT Arcade README, you can find more details on what you have to do to actually set up this repo. But I'm going to go ahead and run the command to start the server, which is pxt serve, and then --rb, which I'm not going to get into. And this will start a local server that it'll pop up with the URL I can go to in just a second. I know this looks terrifying, but it's not that bad. Don't worry. All right, there we go. Okay, so I can, one quirk about WSL is that it does not open this thing by default. So you actually have to click on the link. So there you go. There we go. Okay, we have our local host of Arcade. And you might notice it looks different. That's because we've been playing around with the colors in Arcade. So FYI, we're going to be using different colors today, but otherwise it's pretty much the same. So go ahead and open this up. We have our test project. Cool, pretty much the same thing as before. So got two things, overlap, you can see that happens. So we can repo our bug locally, which is important. That's great. All right, back to our terminal. Okay, so we need to leave this process running. This is our server. So I'm going to split this pane into another one using some fancy keyboard shortcuts. And in this second terminal, I'm going to open up PXT Common packages, which is where the game engine lives. So I'm going to go ahead and do code dot, which will open up VS Code. And there you go. All right. So here is pxt.conf packages. So inside here, we have the libs folder, which contains all of the different packages that we share between all of our various editors. And the one we're going to be looking at today, the one that is used the most in Arcade, is game. So that is our game engine and has a lot of the blocks that come with the game engine. So not just the stuff that's in the game category, but also in info and a bunch of other categories. They all come from the game package. That's what we're doing. And we happen to know on Wednesday, we figured out exactly where this bug is happening. It's this code right here. So this is the code we were reading, which we were like, this shouldn't work. And indeed, it does not. So let's remember what we're doing here. So we use a technique called spatial hashing for Arcade for doing more efficient overlap checks, which is basically with all the sprites that we have running in the game, we take them and we sort them into buckets. And actually, we can turn this on in our editor. So if I go into JavaScript here, I can do game.debug equals true. And now you can see these are our buckets, these yellow squares, yellow rectangles, and these are our hitboxes, the white rectangles that are around our sprites. So there's a little fun secret power for you if you ever want to turn that on. It's not really useful, but you can do that. Curious why this one's highlighted.
I was wondering that myself. I was trying to make sense of some of these buckets.
How many sprites do we have right now? Let's check that. So we're going to do show stats. Head on back over. 2 sprites. I was wondering if there was like some sprite in the background that wasn't actually drawing to the screen. Those. All right, we'll investigate that too because I'm curious. I don't think it's actually causing any problems. But
if you scoot all the way to the left and then bring it back, does it go away? And then like pull it. Oh, strange.
I think it's tied to that other sprite. I don't know what's causing it. We'll have to figure it out. Okay. So anyway, what we do is all of these squares represent a bucket, and we basically put the sprites in all of the buckets that they overlap. So this tall sprite is going to be in these 1, 2, 3, 4, 5, 6, 7, 8 buckets. This horizontal sprite is going to be in this 1, 2, 3, 4, 5, 6, 7, 8 buckets, and possibly this one, but don't worry about that one. And then what we do is when we do an overlap, the idea is we check all of the sprites that are in the buckets that it overlaps with. So in this case, these guys are in the same buckets, which are these 4 center ones. So because they show up in the same buckets, we should compare their pixels, make sure they actually overlap, and then we can fire an overlap event. The basics of the algorithm. But if we look at our code, that's not what we're doing. So this neighbors function is what is returning. And why is this not zooming? How do you zoom? It's control.
Control plus. Should be control plus.
Okay. I'm used to just doing control scroll, but that wasn't working.
Yeah, gets me every time with VS Code.
All right. So inside of this neighbors function, this is where we take our sprite and we merge all of the buckets that they're overlapping with. So you can see right here, we are just calling merge at key 4 times. And this is just doing this left top, left bottom, right top, right bottom. So this right here is what is creating our list of sprites to check. And we are only merging the buckets that are at the corners of these sprites. So when we're doing the overlaps check, we're going to be checking this bucket, this bucket, this bucket, this bucket, and this bucket, this bucket, this bucket, this bucket, where they do not, in fact, overlap. So to make them overlap, we would have to make it so that these guys are in the same bucket. So if I were to move down here and move over here, then, oh, okay, well, I don't know. Anyway, you get the idea. You have to actually have the corners overlap. We're going to try and fix that right now. See if we can do that. All right, so the easy way to fix this, I guess, is I know we're already doing a right here, this insert AABB. So AABB, by the way, stands for axis aligned bounding box. Is that right?
That makes sense. I don't know, but yeah.
Yeah, it's a thing you'll see in like game engines and stuff sometimes. It's referring to the rectangle that is the hitbox of the sprite. So this code is taking the left, the top. It's figuring out the X and Y. So how many cells does it go over to the right and to the left? Then it loops over all of those cells and it's inserting it into all of the buckets. So we're going to just copy this code. And instead of calling insert at key, we're going to be calling that merge at key. I could probably just copy this whole thing and then just change the name of the function.
Key here is referring to a specific bounding box that we're looking up by key.
Yeah. So when we say spatial hashing, that's just the hashing is just a fancy word for the key, which is the specific bucket that we're putting it in. I realize now that key is probably not a simpler way to explain that. I mean, obviously, you know what I'm talking about, but
it's a lookup code.
yeah, it's an address. I don't know.
Yeah.
Okay, and we're going to change this insert at key to be merge at key. Now this is going to complain because I'm only giving it 4 arguments instead of 3. So this should be taking in an X, which it is, a Y, which it is, a layer, which it is. I'm not going to talk about the layer, it's boring, and an array of sprites. So we're not passing in that array of sprites right now. So I'm going to get rid of this sprite. We're going to pass in our layer. We're going to pass in this array of sprites, which is called in. Classic variable name. All right. Gonna save that. And this should trigger a rebuild. So you can see my server is now rebuilding everything. So this will take just a moment. And then when we refresh, we should have our updated code, which will, I don't know, hopefully work. All right, still not working. So let's make sure that our code got applied. So we're going to go to Explorer. We're going to go to Game. Going to head on down to Sprite Map. That's yes. And yep, so there's our code. All right, so this just isn't working, I guess. So we're going to have to debug this a little bit more. Yay. All right. Now, this brings us to the annoying thing about working in PHP common packages. So normally, when I have to debug some JavaScript, what I do is I open up the Chrome DevTools. Just do inspect, open this guy up. Real used to using this. I know all the ins and outs of the debugger and all that stuff. So that does not work for code that passes through the MakeCode compiler. And everything in PHP common packages pretty much passes through the MakeCode compiler. The exception is anything that's in a folder that starts with sim. But everything else is going to pass through the MakeCode compiler. So the browser debugger is pretty much useless. So you might be like, okay, what do I do then? How do I debug this stuff? Well, you know what? I usually just do print line debugging, if I'm being honest, which is not the greatest. I don't love it, but it works.
Can you use the MakeCode debugger?
So you can. It's a little bit broken. So, hey, you know what? Let's try. We're going to the first thing you have to do is if you're trying to debug this stuff, is you have to go into more, go to about, go to experiments, and you want to turn on debug extension code right here. So hit that so it's enabled. Hit go back. The editor is going to reload. You'll get this annoying bar at the top. It goes away. And then now you should be able to set breakpoints in other files. Now, if I remember correctly, this is sort of broken because we don't use it that often. But let's try it. We'll see if it works. So we're going to go into our sprite. Well, first, let's start our simulator. So, well, I think it might restart as soon as I open another file. Let's see what happens. We're going to head over to spritemap.ts. We're going to go into debug mode. It won't let me do that because I'm in a different file than main.ts. Okay, go over to main.ts, start debug mode, then go back to spritemap.ts, not in base, game, spritemap.ts. There we go. Okay. Now you can see on the left here, we have this little breakpoint thing that appears wherever we can set a breakpoint. So we're going to go to our neighbors function. We're going to set the breakpoint right here. And we're going to hit continue to start our sim. And there we go, we hit it. Okay, this is actually working. That's fine. All right, so it looks like our sprites have already been created. This sprite that we're looking at right now is, so the width is 160, the height is 16. So this is our long sprite, the one we're looking at. Let's look at these values that we have. So for x in, that is 4. So that means we're 4 buckets wide. Oh, it's less than or equal to, so it's 5 buckets wide. I believe that. That looks about right for what we were saying before. And then we have y equal 1, so we're 2 buckets high, because I think the buckets are aligned on the center of the screen, so we're in 2 buckets. So that seems right. I think we're calculating that correctly.
It was drawing 4 buckets by 2 buckets, but I believe that there's a 5th one that's like off the edge of the screen in one direction or another.
Was it drawing 4 buckets?
Mm-hmm. Well,
Okay,
except for that weird one in the corner, but.
Oh, yeah. Okay, well, it's roughly correct. If we check more buckets, that's not going to be our issue, so.
Yeah.
All right, so we're going to step till we get here. All right, so now we're at this merge at key. So what does this merge at key function do? Well, it should take in an x value and a y value, and basically go through all the sprites that are in that bucket and then add them to this array that we're passing in. So we're passing in this in array as our last argument. And this should be basically going through everything and just trying to figure out, like, at this key, should we be adding it to the bucket or not? So I'm going to go ahead and step into this right there. Didn't like that. Oh, I stepped into the getter.
Oh, classic.
Step out. Yeah. Okay, we're just going to put a breakpoint inside merge at key. It's gonna. We have a bunch of getters that are in there, so put that right there. Continue. All right, now we're here. Okay, so we have an x equals 0. We have a y equals 68. That seems about right. So, yep. We're going to get our key. So step over this. That is returning the key of 8. And we're getting that bucket. So let's step over this. We have the bucket, and this bucket contains a single sprite, which is the sprite that we are looking at. All right, so we're just going to keep doing this until we get to one of the buckets where the other sprite should be in. Until this x and y ends up with a bucket that could be overlapping with this, we're just going to keep continuing. So continue. Okay, now we have x equals 40, y equals 52. Now we have x equals 40, y equals 68. X equals 80, y equals 52. Okay, this one should be overlapping with us. And hey, you know what? Looking at this right now, looks like we detected it in the last bucket because we have that sprite in our.
Yeah, I was going to say, I think one of the earlier iterations probably had it too.
Yeah. So it looks like this merge at key thing is working correctly, which is interesting. Okay. All right, let's take off this breakpoint. We're going to go back to where we were before.
Yeah, where's the neighbors thing getting used? Because there's still more checks we have to do once we get the list of sprites.
Well, first let's continue to the end of this so we can make sure. Yes, so our array has 1 sprite in it because we removed ourselves. So this neighbors function is now working correctly. Great.
Is it it's the right sprite?
Oh yeah, we can check. So we're in the horizontal sprite right now, so we want to make sure this is the tall sprite. And height 120 looks good.
Yep.
All right. So I think this is, yeah, so we can see in our call stack, this is getting called from this overlaps function. So we're getting our neighbors. We are then filtering our neighbors by the ones where sprite that overlaps with equals true. So let's go ahead and set our breakpoint right here. We're going to continue, and we got false.
All right.
Interesting. Okay.
Uh,
All right, well, I guess we have to go put a breakpoint inside of overlaps with.
yeah.
Right, so that's going to be inside of sprite.ts. Overlaps with. Going to go ahead and just set that breakpoint right there. Hit continue. And get rid of these breakpoints. Is this just not getting called?
I would put a breakpoint in the.
Oh, hey, you know what? This
function
is
that's-
stopped on the breakpoint. It's just.
Oh, it just didn't.
It just didn't
highlight it.
jump to the line.
Or jump to the file. Yeah.
Yeah. Okay, so
Okay.
this is the tall one, and other is the
Wide one.
wide one. Okay, cool. So we have our two sprites correctly. That looks good. So let's just step over, make sure we're getting past all of these initial checks. So step over, step over, step over, step over. Good. Okay. So we have this other dot hitbox overlaps with this dot hitbox. Let's step over that. I can see this one. Yeah. Okay. So this is failing, which is interesting. So can we look at our hitbox, I wonder?
That would be
No.
the. Oh, you're looking at the debugger itself.
All right. Well, we just got to go to hitbox overlaps with. Is this just checking the four corners?
Yep. I think so.
Okay, we have to look at the Git blame on this. I can't believe this was implemented this way originally. Okay.
Cross my fingers and hope it wasn't me.
It was probably me or Joey. All right, we're gonna go. So Git blame, a badly named feature, is a way to figure out who made a commit and like link to that commit. So we're not doing this because we actually want to blame somebody. We're doing this because hopefully it was part of a pull request that was fixing a specific bug, and we can then figure out, is there a reason that we're doing it this way and not doing it the normal way? So
yes. Should. Hence the terrible name for that feature.
Yeah, blame sounds very accusatory, but it, there you go. I know there are some people who like want it to be changed to like
Git understand.
What?
Git understand. Help me understand.
Well, that's a nice one. Or attribution is another one.
Yeah, that's more logical.
All right, overlaps with sprite scaling support. Oh, interesting.
Huh.
Interesting. Okay, so let's look at all of this change. So this was the thing that added support for sprite scaling. So, we have the scale X, scale Y that you can access from the dropdowns. And
I have a hunch that this is probably just going to propagate. Like the issue already existed before this, and we just updated some of the, how things are referenced. But
let's see.
You can see.
What I'm wondering is, did this also change sprite map? Nope.
Interesting.
All right. Overlaps with. Okay, so we didn't even have an overlaps with method before. We were probably just doing it in place. So let's go over to that, the sprite overlaps with, which was probably doing the comparison there and just got moved into the hitbox. Okay. All right. Okay, looks like we were not comparing the hitboxes at all before. Right. Okay, so this is probably just trying to bail out of the blit because the blit is an expensive check.
Yeah.
Yeah. Okay. Right. So the way that our overlaps works is we have some C++ functions for drawing sprites, right? And these functions go pixel by pixel through the sprite and copy them over to the memory. It doesn't actually go pixel by pixel. It does it a little bit more efficiently than that. But the basic idea is it copies it from the memory of one sprite to the memory of the screen. Now we use these same functions because they're going pixel by pixel to check for overlaps. And when we're just drawing the sprite unscaled, we just use the usual, we use overlaps with, which just calls the normal draw. But for scaled sprites, we have to use this thing called blit. Now, I never took a graphics class. Did you?
I did, but please don't ask me what blit means.
Okay, all right. I don't know what blit means. I know it is a graphics term.
Yeah,
but
it rings a bell from years ago, but I'd have to look it up.
Yeah. Basically, I can tell you what it does, though. So the blit function takes an image and it draws it scaled into a rectangle on another image. So basically, you take in the first image, you take in the rectangle you want it to be drawn to, and you draw the second image in that rectangle. So it stretches all the pixels to make it work. And that's expensive because we're making the image bigger or smaller, and we also have to do a bunch of math to determine which pixels are making it into the image. For example, if we get smaller, basically we have to do a little bit of sampling, right? Because we need to, we can't fit all of the pixels inside of a smaller rectangle. So anyway, that ends up being an expensive check. So this hitbox overlaps thing, I think, is just trying to bail out beforehand. Now, what I think here is, I don't think this hitbox overlaps with needs to be implemented this way, though. And I'm actually...
Yeah.
So let's look at this contains function. So this is just doing the overlaps check I would have expected it to do. All right, well, let's go ahead and make the change. We'll test it out, see if we run into any problems.
See if that fixes it.
Yeah. I'm pretty certain it'll fix the issue. I'm just worried if it's going to create some other issues,
Yeah, you never know. I feel
Mhm.
like you get deep into the internals, lots of things call that same code.
Yep. Okay, so what this is doing is it's checking our four corners and their four corners. So this new one should actually be faster than this. But yeah, I don't know if, like I said, I don't know if we're going to end up breaking something that we just haven't thought about here. So we're going to have to try to test it thoroughly and see what happens.
Yeah.
Okay, well, you've seen us do this on stream before, but how do you write an overlaps check? It's very easy. So what you actually do is you write a not overlaps check, and then you just put it inside of a not, because it's easier to think about that way. And to figure out if two rectangles are overlapping with each other, basically what you want to say is the right of the other rectangle less than the left of this rectangle? Which, if you think about that, that means that we are all over to the right. There's no possible way we could be overlapping on the X. And if we're not overlapping on the X, can't overlap on the Y either. Well, we can't overlap on the Y. You can. Then we do the opposite check, which is that other dot left is greater than this dot right. So doing the same thing, but in the other direction. We're going to do other dot bottom is less than this dot top, or other dot top is greater than this dot bottom. Okay, now some of these have to be greater than or equals to. I just don't remember what our convention is inside of the game agent. So I'm going to look at that contains function because I'm guessing that Eric did it. Okay, we're doing greater than or equal to for all of these. All right, so to maintain that compatibility, I'm going to go ahead and just do, what did I do? Come on. Right. Like that. And we'll see. This might cost an off by 1 errors, but we'll just have to try it out and see what happens. All right, save that. Our code's going to rebuild. Have you ever met anybody named Rufus?
No. Calls to mind someone with a very burly mustache. Like I have a very
Does.
distinct image, but I don't know if it's because I know someone that I don't know that well, or if it's like a
What does
a
Rufus Wainwright
well-known
look like?
person.
The only Rufus I can name.
I don't know. I don't recognize that name.
Musician.
Wainwright. Definitely doesn't. Well, some of these pictures he has a mustache, you know, full beard and mustache, but
Okay.
some of them he's pretty clean shaven.
All right, we have fixed the thing. It's turned red
Hey,
now.
look at that.
We haven't yet determined if we've actually fixed it or it just happens to be running that code. So we need to do some more tests. So first off, let's make it so our sprites are not overlapping. So I'm going to go ahead and set the top of my vertical sprite. Hey, get in there, come on. To be lower than this sprite so that they're not overlapping. So we're going to make this 100, which should be still on the screen, but below. So there we go. Okay, cool. We're not overlapping. It's a good sign. And now when I move up 1 pixel, they should be overlapping. There we go.
There it is.
Can't really
See
move one
that
bit.
off by 1 error there, I think, with that hitbox.
Yeah, I don't actually know if it's just how the hitbox is being drawn or if it's an actual
Fair.
off by 1 error, you know? It gets confusing because the hitboxes are they're stored as fixed point numbers, right? So they're floating points, but we're converting that into the integer space. And we might be just doing that differently in the hitbox draw function as compared to the draw the sprite image function, which, you know what, we can fix that too while we're doing while we're, you know, mucking around in here because we might as well. Okay, well, anyway, preliminary results are good. I would say.
Yeah. Promising.
Yeah. All right, so we'll do some more tests. Right now, though, because it's bothering me now that Thomas has pointed it out, let's fix that thing that's drawing the hitboxes. So we're going to look for the code that is drawing these. Now I can't get it to. Okay, there we go.
Oh, there it is.
So we're going to look at the sprite draw code, and we're going to look at the code that's drawing the hitboxes and see if what's the difference there. So I'm going to guess this is inside of sprite.ts. I'm going to search for game.debug. There we go. Okay. So if game.debug, we are drawing the hitbox like this. Okay. So that's where we're drawing the hitbox. Where are we drawing our... Okay, so this is inside of the draw debug function. I want to look at where we draw our sprite right here. And here, let me do some fancy VS Code things. I'm going to open this on the right. I'm going to open the draw debug on the left so we can compare kind of how we're converting these coordinates over. Okay. So here's where we're drawing our rectangle. We're drawing our sprite with this draw left, draw top that's getting passed in. Okay, go to that. Draw sprite. Sorry, go to where this is called. Up here. Okay. So we are passing in. Okay, so in this one, we are doing this fx2int minus offset x. Fx2int minus the top. Here we're doing this dot left and this dot top minus OXOY. Okay, so this one is converting to an integer. This one is returning the floating point number, subtracting the offset x, and then doing the floor. So yes, these could mismatch.
Yep.
Right. So it looks like we're already passing in this same left and top to this draw debug function. Sure seems like we shouldn't be doing this. We should just use that left top and then the hitbox width height.
Yeah. No. Surprised.
So, yeah, let's go ahead and do that. Left. Top. And there we go.
Will the hitbox always match the left and top that are passed in here?
Oh, you know what? That's actually a good point. It's possible they won't. So, you know what? Actually, I don't know the answer to that. Let's look at the getter for this dot left. Okay, so for left, we return this dot x, which is no, so these could mismatch. Yeah, okay, this is no good. All right, so for the hitbox, let's go ahead and make a sprite right now that demonstrates this. So I'm just going to pull out this code for now. We're going to go ahead and make a sprite. We're going to give it a 32 by 32 image. And we're going to draw our sprite down here. Bump, bump. He's happy. Okay. All right. So you can see our guy is down here, and we are drawing this box around it, but we are drawing. Our image is actually bigger than that. And if we go into extensions, go to oh, I want to add Joey's extension. Okay, so inside of Sprite Utils, we're going to go ahead and grab a render on z-index. And we're going to do an image. Draw a rectangle in screen, and we're going to pass in our sprite left, sprite top, width, and bottom just so we can see it. Go ahead and make this not pink because it already teal. Get in there. What is this doing?
Seems like an odd, yeah. What is going on?
This might be a new Blockly bug.
Mm.
That one works fine. Huh, okay, might have to look into that. Okay, so there we go. This is drawing that rectangle we were talking about. This is the hitbox. So you can see our hitbox is actually smaller than the rectangle of our sprite. So what we're going to do instead is we're going to convert it in the same way that we're converting it over here. So what we're doing here is we're finding the offset x, offset y from our camera, which I think we're already calculating up here somewhere. Or maybe we're passing it in. Yeah, we're passing it the offset y. It's great. Now we're going to do, so we have this dot hitbox dot left minus offset x. So instead of converting this to int, we're going to do to float. Then we're going to subtract this, and then we're going to take the math.floor of this. Like that. And I think that should do
Nice. Hope so. Seems like it would.
We'll see. All right, our code is rebuilding. Actually, you don't have to wait as long as I've been waiting. It's pretty fast for doing when you do changes in PXCon packages. All right, now we're gonna move our sprite around and see if we can get that thing to not line up correctly. It's looking pretty rock solid to me, though.
Yeah, looks pretty good.
Yeah. Hey, notice how, hey, there's no mysterious bucket being drawn on this one.
Yeah. It is kind of weird.
Let's add this code back in. Okay. The mysterious bucket is back.
Hmm.
All right, well, that code is what we're going to look at next. All right, we can close this now. So let's look at where that thing's being drawn. I'm guessing it's inside of sprite_map.ts. Okay, so inside of this draw, when we're going through all of our buckets, we're seeing if the bucket has length and we're drawing this rectangle. Okay, so we have an extra bucket that has a sprite in it that should not. So, all right, let's use the debugger. Figure that out. Okay, so I need to simplify my code so that I'm not hitting this a million times. I'm going to throw this away, throw this away. Sorry, friendly guy, you're gone too.
Its purpose has been fulfilled.
Okay, so just this sprite is enough to make this mysterious bucket appear. And let me move this guy around so we can figure out what's happening. All right, well, that's even more bizarre than we thought it was. Oh, no, I get it.
Is it a screen wrapping thing? Like
It's
like
wrapping.
wrapping
Yeah, so
over?
that's it drawing the buckets that are to the right of this.
Huh. Yeah. So it is
okay.
drawing that fifth one that we were noticing in the
Exactly.
debugger.
Yeah.
That's interesting.
Well, that should be easy to fix. Okay, let's look at the code again and see if we can see that happening. Okay, so we're doing x is less than this dot column count, y is less than this dot row count, left equals x times cell width, y equals times cell height. Note that we are not taking the camera into effect here at all, so that's great. And then we're doing draw rect at this left top cell width, cell height, and the color is 5. Okay, well, at first blush, this seems fine.
Yeah. Maybe it's to do with the key. There's like a clash. If
That might be
left
right.
and top, what's the word? Clash is not the right word, but
yeah. Okay, so we are doing xi plus yi times this dot column count. Yes, that's bad.
Yep.
That's bad.
That'll do it.
Okay. Wait, no.
How does this work when there's like a full tile map that's bigger than the screen?
It's a good question.
Confused.
Wait, no, this should be okay. Shouldn't it? We just have an off by 1 error?
Just thinking through. X plus y times the column count. Oh, sorry, order of operations. I was thinking of x plus y. Yeah, so y times the column count plus x.
That should be fine because every time y increases, it should be knocking it down a whole nother, row. So I think this should be fine. I think we have an off by 1 error.
I believe it. Yeah.
Let's debug it anyway. So we're going to head over into JavaScript, do that same thing we did before. So we already have our experiment enabled. It stays enabled. So we're just going to go into debug mode. Got to remember before I switch files. Okay, and head over to sprite_map.ts, which is not inside of base. Game. sprite map.ts. All right. Now we're going to go to draw. Go. Just hit a breakpoint right there. Go ahead, hit continue. And I'm going to continue until I get something on the screen. Okay, cool. All right. So if we were remembered correctly, column count should be 5. Column count is 4. So how has this been working? I guess where's column count used? So column count equals integer divide area width by, yeah, so this should be ceiling. Both of these should be ceiling.
Mm-hmm. Integer divide just rounds that.
Integer divide doesn't round it; it cuts off.
Or floors. Sorry, yeah. Math. Yeah. I haven't seen it done with math.idiv before.
Yeah, so math.idiv. I don't actually know if this is a JavaScript method or something we added.
Oh, okay. Yeah, I don't recognize it.
But it forces integer division, which is faster on hardware.
Makes sense.
I'm actually curious. Is this something? No, it doesn't seem like it. Oh, MakeCode. We also have math.imol, but that's less useful.
Yeah, I think if it was the wrapping issue, if we would, if you were to move the rectangle further to the right, we would see more and more cells appear at the bottom, which wasn't happening anyway, if I recall correctly. So.
Well, no, I think we'll never see more than one appearing there.
With an off by 1 error, I think that's true.
Yeah.
Yeah.
So let's get rid of this breakpoint and just look at the code again. We'll look at it running again. So if we head over to the right, yeah. So that's doing exactly what I would expect it to do, which is that we just have an off by 1 error inside of our code that we're doing. Now, this could explain some more bugs, I guess. Now, if I think about this logically, I think this is a very difficult scenario to actually hit such that it would cause a bug.
Yeah, because it's doing, this is just filtering the check, right? And then it does a more involved check later on. So
yes. So the thing that could happen here is if we had 2 sprites that are overlapping, one that is fully contained in the last row or something. No, it's possible they would just get translated down here. So yeah, I think the issue is just that we could have some extra checks that we do.
Yeah, just a performance thing.
Yeah.
Pretty minor one too, but yeah.
Well, let's fix it. So column count and row count should be, we should take this and we're going to, let's see. It doesn't matter if we use idiv here. So this idiv was probably used for performance reasons. So instead, we're going to do math.ceiling and then do an actual division.
Would integer division +1 always be the equivalent to a ceiling?
No.
I guess not. No, not if they're evenly divided.
If it's exact,
yeah,
it'll be off. Yeah.
Yeah.
Okay, cool. Now, I do think this will always be an integer, but actually, I don't know how we calculate this cell width. So we're doing the cell width based off of the max width, max height of sprites. Wait, we're taking the max width, max height. Then we're doing the 8 area width. Well, okay, so the min is 8, the max is area width divided by 2, and then it's max width times 2. Okay, wait, this seems like we could end up with some big buckets here. but whatever, that's fine. Okay, so and then let's look at where row count and column count were being used. So it was just being used in the key calculation. Anywhere else? And the draw. Yeah. Yeah, so I don't think this would have actually caused any bugs, just some perf issues, like we were saying. And anyway, save that. Wait for that to rebuild.
I'm trying to think if this means it was missing a bucket that it should have been checking.
I don't think it does. I think what's all it's going to do is make it so that the ones that are in the last column bucket are also going to be added to the first column bucket for the next row down. So, and those ones are going to be in the bucket for the other row. So all we're doing is having our columns overlap with each other.
Yeah.
Which is going to cause extra checks to be made, but the overlaps check is just going to throw those out because it's doing a proper check. So
that makes sense. Yeah.
Yeah. All right.
Oh, sad. Did we get the update?
Yep. Well, let's go ahead and put a breakpoint. Go back to game, go back to sprite map. I really love how this collapses itself every time we're doing that. Okay. So we're going to put our breakpoint right here. Inside of this draw. There we go. We hit it. This and we have our row count and column count are the same as before. All right, hit continue. We're going to go over to our resize buckets function and stick this right here. Go. Okay. So we've already set our cell width and cell height, which are equal to 40 and 30. That looks about right. And then we have our area width and area height. So our area width is 160. Our area height is 120. So wait, I'm confused. How does this work if we're bigger than the screen?
Well, it says I'm assuming tmap is tile map. Yeah, so if we had a tile map set, then that would be
right. But if I do stuff like this.
Oh.
Like now that I'm off screen, what is this going to return? All right. Okay, that was a mistake. Sorry. Back here. Okay, so our row count, let's look at what that is. So our row count is 4, our column count is 4. Are we like aligning it? Like, are we figuring out the min X, min Y? Or doesn't look like it. So what is the key we're calculating now? So let's go to where we calculate the key for a sprite. Right here. Continue. Okay, so our X here is 56, our Y is 198, so way outside the bounds. So it looks like we're clamping this between the column and the row count. So we're just sticking everything in the bottom right bucket, bottom left bucket, and then comparing it there. Okay.
That
All right.
would
Who
cause
wrote
some
this code?
that would
Um,
cause some perf problems, I think.
yeah,
If you got a big tile map.
I shouldn't blame anybody. But I'm surprised. I mean, I guess because this only has perf implications, it doesn't have actual like running applications. That's why we haven't noticed it until now.
Hmm.
But this is very wrong.
Yeah. Seems. Well, hey, it'll be great when it's fixed.
Okay. So interesting. Actually, so I don't know what the proper fix for this is because like I know how to fix it, right? Which is inside of this code where we're resizing the buckets, we would loop over all of these sprites. We would figure out what the min x, min y, max x, max y are, use that as our area instead. So do our buckets based off of that, and then calculate that. So that would work. Now, the problem with that would be, imagine I have 4 sprites, and they are at negative infinity, 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 and they're just really far out. Then, if we were to cap the size of the buckets, we would use all the memory on your computer because we would end up with so many buckets that, like, we wouldn't be able to do the comparisons, basically.
So, yeah, because buckets, they have to be contiguous, I guess. We can't just have like.
Yeah. So I guess the way we would fix this is instead of using an array for our buckets, we'll just use an array of objects that just store where they're at, which will be worse for dense fields of sprites, but better for sparse fields of sprites.
This must be a solved problem. I feel like maybe a little research, we could find something.
Yeah. Look into some implementations and see what they do. I feel like they're probably just doing the sparse bucket thing.
Yeah.
I think they probably have a hash map and they're doing the key with, the row column and then just storing it into the hash map, which we could also do. I don't know how bad that is compared to. Have to do some perf comparisons. I think that actually probably doing the hash map is going to be faster for us than doing the thing and just a linear check through an array of buckets. But I don't know off the top of my head. But I think the hash map check will at least be implemented in C++. So
Yeah.
Or assembly. So
I don't know if memory constraints on hardware would be the issue. Is that what it may be?
Yeah, you're right. That would probably cause memory constraints and memory problems in hardware, though, because we would be storing all of those strings, which we don't need to do.
I need
All
some
right.
thought.
Yes, this is going to need some thought. So this sprite map thing that we've been kind of ignoring until now, if you don't have a tile map, is really messed up. If you do have a tile map, I guess it's fine. Yeah, if you have a tile map, it's totally fine. But if you have a no tile map, then it's quite bad. So we'll have to think about this. All right. Well, anyway, thank you for joining us on this journey through the game engine of Arcade. On Wednesday, I promise we'll be back to just working on normal game stuff. So look forward to that. Remember, we have a mini game jam going on right now. It came to us from Copy Sprite. It's pirate themed. So if you go to our forum, you can find the details about that and submit your game there. We will play them all at the end of the month, just like we normally do. And thanks for tuning in. I am Richard at Richard on the MakeCode forum.
I'm Thomas at Sparks on the MakeCode forum.
And oh man, I wish Joey was here. Joey would love to know all of this. I bet you if we showed this to Joey, like a bunch of things would be clicking into his head, being like, "Oh, that's why that was happening." So yeah. All right. Anyway, see you later. Bye.